I think, Amanda, you're doing this one, right? All right, so can I introduce Amanda Ziada, our reporter with Government CIO Media and Research, to the stage here, and she will be joined with our... So thank you again to Jamie for joining us, and I'll hand it off.
Hello. Good morning. I'm very excited to close out our event with our national security panel. My name is Amanda Ziada, reporter with Government CIO Media. Just two quick notes. Please continue hashtagging CXO Tech Forum on social media for our last panel, and we will have time for networking right after this panel. So if we can keep conversation in the back to a minimum, that would be wonderful. All right. All right, so let me introduce our panel. To my right, we have Mike Olson, Chief Strategy Officer of Cloudera. Next to Mike is Todd Myers, Automation Lead at NGA. And next to Todd is Mike Madsen, Director of Strategic Engagement at DIU. So I'd like to start by briefly asking each of you to give the audience a little rundown of what your position entails in your organization. We'll start with you, Mr. Olson.
I co-founded the company 10 years ago. I am an unrepentant nerd, so I grew up as an engineer. But my major job now is talking to our customers and partners about how they can apply our technology. I'm much more a sales asset than a technical asset at this point.
Todd Myers. So I'm focused on automation to accelerate how we deploy large-scale capabilities that are focused on distributed processing for large overhead imagery, as well as machine learning type of technologies and techniques. Lately, we're focused on distributing our clusters between three environments, what we call high side, SIPR, and the low side .mil environment, all residing on Amazon Web Services.
Good morning, Mike Madsen. I'm the Director of Strategic Engagement for the Defense Innovation Unit. We are headquartered in Silicon Valley with an outpost in Austin and Boston, but I drew the short straw, so I'm stationed in the Pentagon. DIU leverages commercial technology to solve DoD problems. So my job in strategic engagement is to work with all the stakeholders in the Pentagon, as well as on the Hill, and working with commercial industry, technology companies, as well as venture capital firms.
All right, so quick overview question. What potential does AI have on improving or enhancing national security?
We work with a number of parties in the defense and intelligence sector, but don't generally talk about the workloads they're running. What I can do is talk about germane workload from the commercial sector that I think is instructive. So if you are a bank, you're required by regulators to know who your customer is and to watch for patterns of money laundering. And it turns out, if you're able to collect a lot of data about the networks of people that are doing business with one another and the patterns of money moving among them over time, that is highly instructive. That's a really useful thing to be able to do. And machine learning is a technique for analyzing patterns of activity in that network over time. And if you're a bank, you also want to know if your traders are engaging in self-dealing, or if you're a regulator, you want to know if traders at different banks are manipulating the markets and prices. And therefore, communications among folks are collected, phone calls recorded and turned into text. The contents of those comms are evaluated for messaging among people. Different algorithms apply in all of those cases. So spatiotemporal activity in a graph, that's one machine learning model on one kind of data. Speech to text, that's another machine learning model on another kind of data. The natural language processing on the text data is something else altogether. But combining those models into algorithms that look for patterns of activity and content of communications turns out to be hugely helpful in pursuing those important missions in the financial sector. And you can imagine really good analogs of those in defense and intel.
What Mike said. So we're exercising very steadfast of applying techniques and technology, using technologies to build a corpus that we can execute machine learning against. And that's going to take some time. We have a lot of data. And we have a lot of data that has to be, have algorithms written in the context of trained data sets. So I wouldn't say that we have majority of lessons learned from AI. I wouldn't even say AI. So we're really focused on making sure that the core of what we're doing from a machine learning perspective has the integrity and then has the provenance to follow that to then execute AI.
Mr. Mattson?
What these two gentlemen said. Just kidding. Many of us have heard and used the OODA loop: observe, orient, decide, and then act. From the Defense Department mission set, we use the OODA loop, and to defeat would-be adversaries, we need to operate faster than adversaries are operating within the turn radius of their OODA loop. But in today's fast-paced world, fast-moving data, we talk about information dominance, information superiority, those type of things. The same way we talk about air superiority and air supremacy in a battle space. But I don't know that information dominance is always going to be doable, and so it really becomes a temporal advantage type of situation. And sometimes that temporal advantage might be enough for the Department of Defense warfighters to remain inside the OODA loop turn radius of our adversaries. And that's where artificial intelligence and machine learning comes into play. The ability to accelerate through that observe and orient steps in the OODA loop to remain ahead of our adversaries. And the situation I just described is a warfighter mission set, but that would also apply to humanitarian assistance and disaster relief as well.
So, Mr. Myers or Mr. Mattson, do you have use cases or projects in the works right now involving machine learning, artificial intelligence, deep learning?
Yes.
Can you talk about those projects?
Perhaps. So we do. We have orders of 10 to 20 to 30 terabytes to 50, you can guess a size, of data that's being ingested. It's being ingested, and we're applying machine learning algorithms that have been developed specifically using container technologies such as Docker and Kubernetes and Mesos orchestration. That is the mean by which we are able to harness the algorithms and orchestrate them against a swath of this volume of data. That's only the beginning stages, and from that beginning stage, we've been able to generate automated machine detections, right? That's only the beginning stage. You have a detection, now what do you do with it? Now I need to put it into an edge node graph environment so that I can start seeing clusters of activities, right? So there's taking a lot of the data that we're doing now and bringing it into an environment that has been normalized using what I call primitives, primitives that are exactly that you would find in a Facebook data center or an Apple data center, or a data center from Wells Fargo that massively focuses on the correlation of distributed analytics based upon orchestrated container topologies. I didn't say the word system, I didn't say the word transition, I didn't say the word integrate. And the reason I didn't say those words is that those don't have applicability in this language of machine learning. So we're focusing on iterating, failing hard, fast, and bringing in this data so that we can apply whatever algorithm data scientists comes up with, or evoke or bring in code via code pipelines that allows academia or industry or other government organization or the services to have their code come into our environment, to our pipelines. We do a build process and we lay the container and algorithms on the clusters, and then we ingest the data and do that processing. So we are doing this from an extensive standpoint. This is only over the past 2 years. And there's a lot to be learned.
We have one project that we're particularly excited about, and that is for the potential that it can scale across services as well as platforms, and that's using AI and machine learning for predictive maintenance. We partnered with the Air Force and took one airframe platform and ingested about 7 years worth of data. And by the way, the aircraft maintenance world, they collect huge amounts of data that they're just now learning how to manipulate this for things like predictive maintenance. So we took all that data and ingested it, and what we found was that a reportable return of about 30% reduction in unscheduled maintenance for aircraft. Now on the surface you're thinking, all right, 30%, that's all right, about a third, no big deal. But let me put it in context with a quick story. In a previous life, I was a C-17 pilot, and I can recall 2 specific missions. One of them was a warfighter support mission, and one of them was a humanitarian airlift mission, where we departed home station, got to an austere airfield halfway around the world, and upon landing we broke. We could not take off again. So we had to call back and Mother AMC had to generate a part, figure out what was wrong, send the part halfway around the world, send a maintenance technician halfway around the world to repair this. And it took about 5 days for that. So while that's going on, our warfighter mission and humanitarian mission were both delayed. So there's a humongous cost savings here because if we would have had that AI, ML, predictive maintenance, we would have known the part was going to break before we left home station and we could have fixed it there. So there's some cost savings there. AMC, our mobility command, had to generate 2 more missions to go do the mission that we couldn't do because we were stranded halfway around the world. And there was a delay getting goods to the humanitarian effort as well as supplies to the warfighter. So we're talking about time saved, money saved, as well as lives saved, most importantly. And then a side note of particular interest is the increased maintenance reliability rate. So again, like I said, this is something we're very excited about, scaling across aircraft platforms in the Air Force, but also the Army just signed a contract for predictive maintenance on their Bradley fighting vehicle. And the Marine Corps just called me the other day. They want to look at applying predictive maintenance to some of their vehicles also. So there's an opportunity to scale across platforms as well as the services.
Okay, and I do want to talk about the challenges you're facing in these projects, but first I want to ask Mr. Olson, with your experience working with the national security and IC community, where do these agencies need to start or build a foundation for these kinds of AI and machine learning technologies?
Unsurprisingly, these agencies are already pretty sophisticated. So they've got smart mathematicians and technologists who have been using these technologies for a while. As the tech gets better, it applies to more of the mission, more workloads, more use cases, and so on. What we see, not just in government, but broadly across our customer base in the commercial sector as well, is taking advantage of technology in new ways is as much an organizational and cultural challenge as it is a tech challenge. So decision makers often don't pay attention to computers. They often pay attention to paper. The recommendations that can come out of a predictive maintenance system, for example, need to be acted on now, right? It's no good to know that 2 weeks ago I should have fixed the Bradley fighting vehicle. I need to know it right now. And that means the people in the decision chain need to take advantage of these tools while the information is still fresh and useful. And that is a real cultural difficulty. You guys heard about the guy in Japan who was named Minister of Cybersecurity who didn't even use email. Now, it ain't that bad in government, but sometimes there are people who are a little bit allergic to computers. And providing them with appropriate tooling and making sure that they're taking advice from the machines and making better decisions as a result, that requires cultural and organizational change as well.
Are you faced with these changes in these projects?
That's kind of what we do. Before I was with DIU, I was executive director of a congressional advisory panel for acquisition reform. One of the things we looked at was small businesses, because that's where the innovation occurred based on patents that were awarded. And I understand that invention and innovation are 2 separate things, but really it becomes a non-traditional company. And I only bring up that previous job because what we tried to do there was illuminate a pathway to the defense marketplace and lowering the barriers to the defense marketplace to some of these non-traditional companies where the tech is. And so fast forward, that's natural fit working for DIU. That's what we represent, a pathway to the defense marketplace to leverage the commercial technology that's out there to solve some of DoD's challenging problems.
Do you face any challenges, Todd?
So I don't view them as challenges, I just view them as concise direction. So I have a concerted effort under my activity with my team that we're bringing the ownership in on my team to deliver from the government out, and which is converse to a lot of the way things are done, right? So I don't put a description of a document out and then have somebody bid on it, and they develop it in a factory, that's the term we use, and then they throw it over the fence to us and we figure out where to put it in place. We've put the development efforts inside of the government space. And what we're developing is actually going GFE for the government to use. And oh, by the way, we've open sourced it as well. Our activity is on NGA GEOINT GitHub, or GitHub to NGA GEOINT, and you can look it up, and I'm sure you can find out the information later on. And we're doing this for a reason, and primarily is that we wanted to revitalize the skill set and the ownership from the government perspective of having government, federal employees that can code, that can develop, that know about 12-factor app, that know their history, a little bit of their history of what it meant when Alan Turing was programming into what it's been today. There's context there, and it's been completely lost. And you don't get that by buying AI, ML from a company. You get that from developers in government taking ownership and developing against context for mission relevancy. So all of what we've been focusing on the past 2 years through several efforts has been to harness the technology, to deploy our capabilities in a provider environment. Some of it's bare metal, but most of it's going to be a provider environment, such as Amazon, to engage with industry and outreach, such as what this Mike referred to as out in the valley, outpost environments, but to bring that code into the government space so the government can develop and own it and participate and be part of that solution set. So I don't view it as a challenge. I view it as a very concise direction to take ownership back in the government space.
Could I actually add on to that? Mm-hmm. I think you bring up a really good point, and part of it is culture and bringing that back into the government space. And I'll use an example of the Air Force. When I was on active duty, there was a one sheet that summarized everybody's career. And the Air Force admin folks could search by name who in the Air Force spoke Russian, who in the Air Force spoke Spanish. And in fact, they paid folks to maintain that currency. And they just recently started doing that for things like Python. So now they can search and say and find out by name who speaks Python, which is a coding language, that they might have learned in their spare time that their actual job is sweeping the floor underneath the missile in some missile range. But they're starting to track those things to pull those capabilities back into the services. And that's very encouraging to see.
All right, so I want to shift gears a little bit to the ethical concerns of using AI in national security. Obviously, we talked about the benefits, cost saving, life saving, improving efficiency. But a few months ago, earlier this year, Google announced that they will not renew its contract with the DoD's Project Maven after some employees expressed concern over using AI for this mission. We're not going to get into that particular event, but I just wanted to ask, is this a concern in the national security community, and if so, how are you dealing with it? No, crickets. Other ethical concerns of AI?
I'm glad to go first. Yeah, huge, and this is a super knotty problem. We built our company, we were the first player in the space to commercialize some technology called Hadoop. This is big data software, and the ecosystem has advanced a lot. There's much better algorithms. We're doing a lot of really cool stuff. But fundamental observation, this stuff was born for surveillance. That's why big data technology emerged in the consumer internet. And it turns out to be hugely useful for watching large populations of people. I talked about some use cases a minute ago. We're a liberal democracy with a fundamental commitment to human rights. And in general, our defense and intelligence apparatus has been stalwart in defense of all of that. We need as a society to think about the ethical implications of the technologies that we built and how in defense and intel we apply them while preserving our democratic and human rights commitments. You all know that China has invented something now called the social credit score, where they surveil all of their citizens all the time, pay attention to their political statements online, their patterns of shopping, and decisions are made like where those people are allowed to live and what kinds of jobs they're allowed to. Now that is deeply offensive to most Americans that we talk to, but it's a different society operating on different premises. When you think about development of the technologies that we're talking about here, machine learning, we apply them and we think about their application in ways different than our adversaries do. It is an uneven playing field, and we don't have control over the means of production. That is, advances in AI are happening worldwide right now. How we thread the needle, how we think about behaving ethically ourselves while confronting different ethical frameworks and pretty serious bad guys, it's going to be tough. It's going to be tough. One last point, and I won't go into details, but look, I thought when the Snowden revelation happened, at least we might have a full-throated public discussion about ethics of data collection and use. Didn't happen. A whole bunch of other breaches and leaks have happened in the days since. In fact, I picked on the Chinese a minute ago. It turns out the Chinese were responsible for the theft of data from Marriott recently. I really do think that a global society, and certainly American society, needs to debate what is right. In the meantime, I really don't think I need my hotel collecting my Social Security number.
I think it's just a hype. If we did a data call of the percentage of DoD IC systems that are actually mature enough to actually threaten what that question is inferring, it would be laughable. Because the majority of these systems are legacy designed. There's no AI, there's no ML. It's controlled system interfaces, right? Serial command and control type of activities. The question is poking at the hysteria notion that the machines are doing something nefarious. There's no concern.
Can I push just a little bit? Granted, there's a lot of legacy technology out there. Don't we have a responsibility to formulate policy and to create legislation supporting it that dictates how we will apply these technologies in support of our ideals? Don't you think that that's an important thing to do?
I completely agree, but I think that the amount of time that we need to take to mature our approach, how we govern, how we establish the approach to govern with well-informed individuals that know how to compose and use a microservices architecture, and the meaning of what ML really needs to do and what the training label data sets need to be. That's why I really have no issue saying I don't have a concern right now. I think it's overly hyped in the private sector based upon examples that are out in ungoverned, vetted environments in private industry, some of which in other foreign nations. I don't think it's applicable to the U.S., and I don't definitely know that it's not applicable to DoD and IC.
I think we all want AI to be like Ender's Game or maybe what's depicted in iRobot, and it's probably currently more accurately compared to, say, Pong from the 80s. Some of you out there are not laughing because you don't know what it is, so you have to Google it. But I think that it may get there someday. So, and now in this early stage is the time to start addressing those issues. We've experienced no reduction in folks that want to work with us in the Valley. In fact, we have more and more tech companies that do want to work with us because we represent a challenging mission set for them. And let's face it, entrepreneurs love a sticky challenge. But I think the ethical issue is also a sticky challenge that's not a DoD problem or a whole of government problem, but a whole of society problem. And we want as many folks involved in that national debate as possible to come up and solve that. The Defense Innovation Board has been charged to come up with AI principles of defense, which I think is a great start for that, bringing in some folks from the academic world, the industry, and defense to start framing out what this looks like.
Be clear, I agree with Mike entirely. I'm not concerned about the national security apparatus uniquely. We have a broad social challenge in front of us as to how we apply these technologies. I will say that in our experience, our government clients have been absolutely stellar at paying attention to the laws that apply to them.
So maybe we can agree that there should be some sort of AI ethical guideline, regulation, policy developed to help with these challenges in the future as we progress with this technology. Would that help?
Well, I think it certainly needs to be part of the national debate.
Mm-hmm.
Yeah, I absolutely think so. We have a blunt instrument that we've applied in the past to technology, export control, that we've tried to use to contain how this tech gets applied by the bad guys. I don't think we have that possibility here. I think that the techniques and the mathematical skills are global. For sure, in the US and in the commercial sector especially, we need better ethical policy and control. How we think about that globally, that's going to be hot. That's going to be tough.
Okay. Next topic. Todd, I wanted to talk a little bit about your deployment of a multi-data center and cloud processing clusters for NGA. You're using machine learning and deep learning for that, and we talked about the challenge of scalability. Can you explain that a little bit?
Sure. So we've taken advantage of machines that are easy to spin up, and we've laid a orchestrator on top of that. It's an open source activity, Mesos and containers and whatnot, Kubernetes, et cetera. I don't really have a favorite one, but we do have a direction, and the direction is that we didn't want to go down the path of being bound by an environment that dictates how we write an API or interact with an API. So we wanted to make sure that wherever we deployed, we could focus on the transportability to evoke algorithms, mission data pipelines, to ingest mass amount of data, to index mass amount of data, to run ultimately hundreds of thousands of algorithms, whether the data comes in and it's a Kafka stream and an event, a topic, and then runs through Spark. I need to run NIDF extraction, which is information about the metadata that tells us information about the image file, and whether we need to extract run out other algorithms to extract more information to do detection. These are all going to happen, right? This happens today. I rode the metro in, and as I'm riding the metro, it's giving me spatial temporal information, and that's being referenced on a map, and it's being referenced on a map based upon a correlated detection, based upon data that's stored, I guess it was a Google map, that's being streamed back to me. So the approach is to don't think about system designs, because system designs require a static definition of design state. Think of things that live for a second, they do their job, and then they move on. So our activity is focused primarily on establishing what we call core, and core has technologies and techniques and process that allows us to insert, like a Lego block, any technology or any process that follows these principles. And the principles are very simple. It's extremely simple, and it's ironic that we're talking about machine learning and AI, but the principles that's going to greatly enable this is based upon three things, three simple things. Code to source, source to a pipeline, pipeline to delivery of evocation in a container namespace. It's that simple. And if you scale that and you focus on that deployment model, no matter what you want to evoke or what you want to work on, whether it's a stateful or stateless application, it can be managed. Now here's the challenge. The amount of activities or organizations that understand what I just said, that can comprehend what's required to do in their organization to remove all of the system designs and bring in a fabric of orchestrated microservices based upon container topology is foreign. It is not the norm. So if we're actually going to harness machine learning and AI to go forward and ingest mass amounts of data and have correlated analytics that have meaning, then we have to normalize these environments. And so that's what we focused on. We focused on developing a core. The core will use the technologies of the day. The core will be deployed in cloud environments. The core will be deployed in other environments, bare metal, other activities. But we won't focus on deploying a system that does one thing, right? So we need to be flexible. So by doing that over the past 2 years, we've successfully been able to ingest major overhead data at a scale that's never been done before, at a cost that's orders of magnitude so absurd, I won't even tell you the number, less. And we've greatly enabled the developers to iterate and fail hard fast against their code. So when we bring in an activity or capability, we do component testing, blue-green deployments, just like Facebook and just like Apple, just like Twitter does today. There's no difference. There's no need to reinvent that. We have Scrum Masters, and we have activities that focus on gathering user stories and following the principles of Agile methodology and so on and so forth. All of that is all part of this process, and all that requires an investment of the organizations to understand you just don't go out and buy this. You actually have to own this. You have to be participating, and you have to make others become participants as you go forward. So by doing this, we've greatly transformed the legacy systems of it did one thing, and now it's just a blank slate, so to speak, a canvas that people can create as they want to. They can bring in data, they can write their algorithms, and they are able to control their destiny to some degree, and they're able to share that data and those analytics at a much better scale.
All right, so I want to close by asking, Mr. Mattson, we talked earlier about how DIU changed the business model to focus more on DoD's mission rather than the new technologies out there. And Todd, along with what you were saying about the techniques used and not reinventing the wheel, how can government and industry work together going forward to properly implement AI and the technologies it brings efficiently?
Well, I think the first thing is we need to focus on fundamental research. We need to make it easier to do business with the government. I mean, let's face it, it takes large muscle movements to do business with the government and DoD for sure, which is what we do in DIU. And then I think we need to reinvest in ourselves, increasing STEM education. So what we do is you alluded to our business model, we look for a DoD partner with a challenging DoD problem, and then we help them curate it and make sure it's not a list of requirements, not a description of a symptom of the problem, but the actual problem. And we're looking for a short statement, half a page, a paragraph. I think our shortest is one sentence. It was a run-on sentence, but one sentence nonetheless. And then we push that out to the tech industry and get solicitations on how they think they can solve that problem. And then we work as a facilitator between the Department of Defense partner and the tech company to come to a resolution on what that looks like, and we look to award a prototype contract within 60 days. We're averaging a little bit higher than that right now, but our goal is right at 60 days awarding a prototype contract. And then we look to field that technology within 24 months, so it's fairly rapid. And we have a lot of authorities granted by Congress to rapidly acquire things. We need to, again, make it easier to do business with the Department of Defense. The other thing we need to do is increase the national security innovation base, and that's one of our other things that we're looking to do by reaching out to a lot of tech companies. Getting back to the triangle that really birthed Silicon Valley back in the 70s, that triangle of industry, government, and the academic world, we really need to get back to that and build that national security innovation base up.
I'll close the way that they began, what they said. Both Mike and Todd have talked about agility and speed and organizing for embracing the technology in support of the mission. All that's fantastic. The only thing I'll say from industry's point of view is that while government needs to get maybe a little bit more agile, at least in the large, industry players who want to work in this space need to take very seriously their obligations, right? And a lot of dinky little Silicon Valley companies are willing to tolerate failure, downtime, security issues in the commercial sector that simply can't be tolerated in this space. So I think that those of us in the Valley could take a lesson from some of our colleagues on this coast as well about the importance of reliable, robust, and bulletproof systems.
Did you say you were going to close? Can I add one more thing? So I have an extremely high expectation. I have a barrier to entry of how industry or developers work with our expectations. And because the stuff that we're doing, there's no error ratio. It has to be on target. The detection has to be a detection. It can't be, oh, well, we were close, right? And so my bar is extremely high. High like Uber high, where you expect to get in an Uber and you expect to give your location you want to go and you expect that car to go there, right? There's a lot of data that's being processed to provide what looks like a really simple app. But that bar is extremely high. And right now, we're nowhere close to that bar. So there's a lot that industry and government on both sides can get to that bar. And it requires all of what we just talked about, plus understanding that the days of designing a system to sell to the government are gone. The days of iterating capabilities that can fit into distributed architecture are here to stay. So the more you interact at that level, the greater opportunity becomes for everybody in this room and the government to receive.
Can I add one more thing?
Sure.
So in this area of great power competition, we are in a tech race. And it's not just for the technology we're talking about, the foundational technology, AI, autonomy, robotics, cyber, those type of things. AI certainly is one of the most important. But it's not just winning that race. If we lose that race, we will exponentially lose the race for all the future applications and products that spring from that.
Okay, I don't think we have time for Q&A, but we do have a networking break after this, so hopefully you can catch one of them after. Thank you guys so much for joining me today. Really appreciate it.
Thank you.
Thank you.